Okay, so for this part, you're looking at some non-right triangles. So the key to a non-right triangle is that there's no 90-degree angle. So this is what kind of sets you apart based on yesterday's lesson and today's. So the key is that you do want a pair of information if you're using sine law, and then we're also going to introduce you to some cosine law. This is significantly harder than yesterday, so you definitely want to make sure that you're trying every single question in order to get the correct solutions. So again, we can actually use these on right triangles, but it doesn't make sense for us because it's a lot more work. So if you're using right triangles, you want to use what we did yesterday with SOHCAHTOA. If you are working with non-right triangles, you're going to want to use sine or cosine law. The key and the rule of thumb is that you want to use sine law whenever you possibly can, because it's a lot easier and the steps are a lot more straightforward. But if you need to, you can also use cosine law, of course. So you've got two different things to pull from here. So we're going to start with sine law and then breeze into cosine law. The first thing is we want to make sure we can calculate a length. That's usually where we start. But even before that, we should go ahead and label our triangle. How you label it is up to you. It doesn't really matter where angle A is. But the key is that your pair of information, so your side and your angle, must be directly across from each other. So for this one, I'm going to label it the same as they did on the module. So you have angle A, B, and C. So you'll notice that in the module as well, so they labeled all the side lengths that are directly across from the angle. So the question mark, we're going to call A. This down here is B. And then directly across from angle C is sine length of C. So when we're using sine law, it's very easy. It's just a ratio. So sine of A over A is equal to the sine of B over B. The key is your unknown value that you're solving for, you want on the top of your ratio. So that's what we're going to do. Your unknown should always go in the top left-hand corner. So for example, when we set this up, same thing, you're going to do the side length of A right at the very top left. Because it's already pre-isolated for you, it's going to be a lot simpler. Over the sine of A. We're going to set that equal to whatever our pair of information is. So for us, it doesn't make sense to use B because we don't know either the angle or the side length. So we want to make sure that we're using the angle and the side length of C. If you put one side length on the top, you must put the other side length on the top as well. So if you're solving for a side, keep it easy. All the side lengths must be on the top. When we get to the angle, it's going to be the opposite. All of your angles must be on the top. Your next step, so once you get set up there, you're just going to be plugging things in. Your angle A is 45. And then your side length of C is 19.4. Okay. You're also going to have your sine of C. Be careful, that sine needs to be there. And for our angle measure, it's 55 degrees. Okay. Nice and straightforward. So if you think about it, the sine of an angle is just a number, so treat it as so. Right here, we basically have A divided by some numbers equal to all of this on the right side. So the only last step you need to do, you're going to take your sine of 45 and multiply both sides. Whatever you do to the left, you must do to the right, so that will cancel out and leave you just with your A. Okay, so just like if you had 2 divided by 2, it equals 1. Same thing, these two will cancel out. When you're typing this into your calculator, there's no inverse buttons, so no shift or second function. You're just going to type the regular old sine button, so it's sine of 45 times by 19.4 over the sine of 55. When you get your answer, make sure that makes sense. So when I calculate this out, A is about 16.7. You're also free, of course, to add back your units, so this would be centimeters. So there's your answer. Does it make sense? Yes, because the 45-degree angle is directly across from a slightly smaller side length than the side length of C. So that's exactly how you do it with a side length. We'll do one more super quick. So again, we'll go a little bit faster because you've already seen the answer and how to approach your steps. We're asked to calculate the side length of y. So for this one, first step, we want to make sure that we label everything up accordingly. This would be the side length of x. This would be y. And this would be z. We're going to do the exact same thing. So we're going to highlight all of the pairs of information. For this one, we actually don't have a pair of information. So we don't have an angle and a side with the same letter. However, if you notice, we know that all three angles connect to 180. So we can easily detect what angle x should be. Just like the steps outlined in the module, you can take 180, subtract by 50 and 60, and you're going to be left with 70 degrees. So right there, you just easily solved for your angle set. You now know angle x, and you know the side length of x. So we want to make sure we incorporate this pair. For us, we want to calculate the side length of y, so of course we must use that. And we know the angle of y is 60 degrees. So same thing, you're going to keep your unknown in the top left-hand corner. You're going to do y over sine of y is equal to x over sine of x. You're going to take everything and sub it in. So again, when you're solving for a side, all the side lengths must be on the top. So stick with the same process. Our angle of y is 60 degrees. Okay. And then you're also going to take your x, 8.2, and your sine of your angle, which we just solved for, was that 70 degrees. You're also going to multiply both sides by the sine of 60. This will essentially cancel out the denominator on y. So that way y is isolated to the left. Good notation. I can show it, you don't have to show it. This is a good visual just so you can see it canceling out. And whatever you do to the left, you must do to the right. Okay. So when we get down to it, we have the sine of 60 times 8.2 divided by sine of 70. So y is approximately 7.6. When we're looking at units, we're looking at meters. Okay. Does it make sense? I feel like logically, yes. Looking at the length of y, it's just slightly smaller than the length of x. Okay. If you got like 14 or something like that, something's gone terribly wrong, you got to go back. So that's sine law with calculating the sides. The next part is angles. So for this guy, you want to solve for angle A, which is this one. Of course, we want to make sure that we incorporate that because we got to solve for it. Same thing, first step, you're going to set up all of your side lengths. Again, I'm just labeling them directly across. So across from angle A is side length of A. Same thing with B and B. C, you can kind of already tell, is going to be pretty useless for us just because we do not have a pair of information. So we're going to take the angle of A, we're going to take the side length of A, we're going to find our other pair of information. For us, we want to tie in the 73 degrees and the 12.5. Exact same idea as having all the side lengths at the top, but now you're searching for an angle, so you're going to flip it. You're going to have all your angle measures at the top. So when I rewrite this out, I'm going to have sine of A over A is equal to sine of B over B. So my first step always to get properly set up so that all of my answers I can verify are going to be correct. Second step, plug everything in. So your side length of A, which is directly across from angle A, is 8.6. And your sine of B, keep all the signs as they are, is over 12.5. Very similar. So you're going to take whatever's on your denominator. You want to isolate for A. So we want to get rid of the 8.6. To do that, exact same process as before. You're going to multiply by your 8.6. When you do that, you're just left with sine of A on the left-hand side. Okay, and that whole thing is all multiplied in. So 8.6 times sine of 73 over 12.5. Apologies, I changed my notation slightly, but just to show you that, again, it's just all multiplied. The very, very, very last step. So if you calculate everything on the right-hand side, you will find the sine of that angle. But what you want to do is actually find the angle measure. So you're going to use actually very similar stuff to yesterday when you're using that -1 button. That will undo the sinusoidal function being applied to A. So the sine of -1 will ensure that you get the angle isolated by itself. So you're going to take 8.6, multiply by the sine of 73 over 12.5. When you're calculating this, your answer must be between 0 and 90 degrees and within reason. So if you get like 110 degrees, you've done something terribly wrong. Doesn't make sense based on the angle measures were already provided of 73 degrees. And of course, we also have missing angle C. Typing this is going to be extremely hard, especially at home. So make sure that you're reaching out if you struggle all with this. Okay. There's also some great applications since you're in an online course. You can feel free to use those as well if you like. But again, if you're not getting a proper answer between 0 to 90 degrees, it's probably two things. A, notation, so that whole thing must be contained within a bracket. Other option is you might have your calculator in radians mode, so it's got to be in degrees. We don't touch radians at all in this course. So that's exactly how you would calculate the sine, or sorry, well, you are calculating the sine, but how you would calculate that angle measure. All right, this one's a little bit more tricky. We're asked to calculate angle M. Now, what you'll notice is if we label everything up, the only pair of information we have is in relation to N. N as in Nancy. So when we label up, we are given 3 pieces of information, but neither of them are related to the angle M or the side length of M. So we're going to have to do a couple of different things. First thing is we are going to have to pull in that third piece of information provided by side length of P. And then we're also going to use angle N and side length of N. The reason being is we don't know anything about M. So our strategy is this, to solve for a second angle, and then we can use angle sum to figure out what angle M should be. Okay. So that's exactly what we're going to do. We're going to start by solving for angle P, and you'll notice M is pretty big. Looks like it's just a hair under 90 degrees. So we'll use that information to solve before we actually get down to it. Okay, so the first step, we are going to try to figure out what angle P is. I'm going to set it up in relation to sine of P and the value of N. Okay, nice and straightforward. We're looking for an angle, therefore we're going to put the angle on the top. Exact same stuff as before. You're going to plug in everything that you know. We don't know what P is. It's in the top left-hand corner. We're expecting that, but we know that the side length is 41.75. We are going to use our angle N, which is 54 degrees. And we are going to also use side length N, which is 54.25. Okay, so that's exactly what we're going to use there. Same stuff as before, we're going to multiply by whatever is contained in the denominator, which is attached to the sine of p. Both sides, of course, in order to fully cancel out. It's going to look like this. Okay, it looks massive and it's a lot, but if you slow it down a notch, take your time calculating, you should be just fine. Exact same stuff as the last question, you're going to take your inverse sine. This will undo the sine being applied to the angle, and it will just leave you with your angle measure, which is all that we're looking for. Okay. So this is what it looks like. Huge calculation, but our end result will be nice and straightforward. So we get down to it, and we're going to calculate this all in degrees mode on our scientific calculator, and we get 39 degrees approximately. Angles are almost always just measured to the nearest degree. We don't really go into 10th or 100th of a degree, so you can leave it just like that. We are unfortunately not done though, so we could fill it in if we like. Okay, and that's typically what I tend to do just as I'm solving for unknowns, is I'll just go ahead and fill in the diagram. Fortunately though, you're looking for angle M, which is this one. Okay, you haven't quite got there yet. Now you could go through sine law all over again if you like, but we do not have the side length of M, so that's unfortunately not going to help us. What will actually help us is we know the other two angles, so we can take angle M, and understanding that they all have to add up to 180, we can just go ahead and subtract the other two angles. Okay, this will give you your final result, which is already in the module of 87 degrees. And there's your final answer. Okay, so again, 2 examples of solving for a length, 2 examples solving for an angle. One is you gotta do a couple extra steps just to get to that angle, but you're more or less just using sine law over and over and over again. Unfortunately, this is the easier of the 2. So there will be a couple of cases where you're going to need to use some cosine law. So that's what we're gonna try right here. There's 2 different ways you can use cosine law. Of course, the first being a side length, the second being an angle measure. It is a long, drawn-out formula, but again, the end result will just get you exactly what you need. So there's 2 different ways that you can use cosine law. One is called a contained angle. So for this example, notice that you have an angle measure, and you have the 2 side lengths surrounding that. So this is a contained angle result. What this will do is it will actually provide an answer for your missing side length. We can't use SOHCAHTOA, it's not a right angle. We unfortunately don't have a pair of information, as you can tell. There's really nothing to grasp at, so the only thing we can rely on is cosine law. How it works is this. It is always expressed in q squared, kind of like Pythagorean theorem, only this time it's in relation to the cosine of your angle. It needs to have some sort of trig ratio because it is not a right angle triangle. So it has to take into incorporation the sides of the angle in relation to the other 2 sides. You're going to take the other 2 side lengths. Again, how you label it is up to you. So you're going to take p squared plus r squared. And then this part's going to be a little bit wild, minus 2, and then times your other 2 side lengths besides q. And then you take the cosine of the angle across from it. So for this case, you must have the angle and the 2 side lengths surrounding it in order to find for the 3rd unknown side length. Besides that, it's more or less just plugging in. It's just very tough to get started because it's a long calculation. So our value of P is 15.2 squared plus your r squared, which is slightly shorter at 12.2, minus 2. And then you also have P, R, and your cosine of your only angle that you're provided in this case, but it's just the angle across from the unknown Q, okay, which is just 63 degrees. When you do this, if you're using a good calculator, which you should be able to type this entire thing in and it should give you a result. This is all multiplied. So it's all multiplied. So it's minus 2 times 15.2 times 12.2 times cos of 63. You never, ever, ever, ever put sine or tangent in there. It's always a cos. When you do this, you'll get kind of similar to Pythagorean theorem. You're going to get an answer that is expressed in the area squared of that side. If you don't get this answer, you need to double check your calculator functions. Same exact thing as Pythagorean theorem. In order to get the side length by itself, you're just going to square root. Okay. And from there on, it's pretty straightforward. You're going to get an approximate side length. Okay. For us, it's about 14.5 meter. You're asked for a side length of Q. Okay, and that's exactly what you solved for there. So you're done. The cosine law ones we'll try to keep a little bit more straightforward because we understand they're long drawn out calculations. So it'll be pretty obvious when you need to use cosine law because it will be an angle and the two side lengths contained outside of it. There is another example for the length, but honestly, it's more or less the exact same. If anyone needs step-by-step solutions, let me know. But again, it looks very, very similar to this. So feel free to reference this example and try it on. You're just solving for the side length of C. The last part is when you're trying to find an angle using cosine law. And then there's a couple of examples beyond that. They're just solving the entire triangle. So you could give those a try if you like. But even understanding these, you should be able to do quiz and any task just fine. So you're asked to solve for the size of angle P. You're looking at this one. So you're provided a formula. It is basically the squares of the two sides minus the side across from your angle measure of P divided by 2QR. So the P basically goes at both ends. It's marked on the module. So we're taking away that square in order to figure out what the angle measure is. If you look back at the previous example with the side length, you could just rearrange that in order to figure out this equation. We are in a very fast-paced summer school program, so we don't need to do that every time. You'll just be given a formula, and of course you can use notes. So first step is going to label up my sides directly across from the angle. So P goes with P, R goes with R, and Q goes with Q. And sorry, that was not in alphabetical order. Okay, so our formula is this. We take the cosine of P, and we have Q squared plus R squared minus P squared divided by 2QR. I personally actually find this one a lot more straightforward. You don't have as much going on, which is nice. You're going to basically plug in everything that you see. Q is 7, R is 5, P is 6. So it's going to be a bunch of squared areas on the top. So again, Q is your 7 squared. And you also are adding your 5 squared, which is R. You're always subtracting the side length directly across from the angle that you're solving for. So for us, it's going to be that 6 squared for side length of P. This is all divided by 2QR. So notice how you only use the 6 one time. Okay, these are pretty manageable numbers. So a lot of it, I mean, you could do pretty fast. 7 squared is 49, 5 squared is 25, 6 squared is 36. Alternatively, of course, you can use a calculator, it's no problem. In the end, you'll get 38, and then 2 times 7 times 5, which is just going to be 70. Your last step, just like you're doing SOHCAHTOA, you're going to take your inverse of cos in order to isolate for that variable. We don't care about the cosine of p, but we do care about is the angle p. Okay, so you're going to take that whole thing, 38 over 70. It's good practice just to keep as a fraction in order to hold all the decimal places. And this will give you your result of approximately 57. Does it make sense? Yes, it's between 0 to 90. If we look at it as well, we can see 57, I think, logically makes sense, even looking at it visually. So again, those are the last two examples. We have one with side length and one with the angle. A lot of times you will be able to pull from sine law, which is why we tend to focus on it a little bit more. Sometimes you'll use a combination. You'll start with some cosine law to get one value, and then you can continue using sine law to continue solving. There's also some information down below about angle of depression and elevation. But for the majority of the quiz and everything, most of them will just look like these triangles, so I wouldn't stress too much about it. There's a couple of real world examples, but besides that, it's more or less just bouncing between sine and cosine law. Hope this helps.